course, anything that we can't get fit within the time allocated, we'll endeavour to get back to you at the end. So I hope you enjoy learning a bit more about implementing security within CI/CD. And if we kind of just quickly start off with regards to how we got here, of course, Azure, the cloud, public cloud, in general has redefined how we've built applications. So as a result, we do have the fact that it's not going to go away. It's here to stay, as I say, and with that, the cloud native journey, not just the public cloud itself, is a big part of how we get there. Implementing cloud native methodologies, cloud native workloads, infrastructure is something that doesn't just apply to public cloud providers anymore. It also applies to on-premises as well. We've got things like cloud native tech, like containers, for example, that's they're running on premises, that don't just exclusively run in the public cloud. So as a result, it's a way in which to ensure that we can deploy our applications in a fast and agile way. Ultimately, most people are using at least two, if not a hybrid deployment of some form. And one of the great things about deploying applications in this way, of course, is that they are automated. They allow us to automate at scale the deployments. But unfortunately, that does come with the fact that we can also automate failure at scale as well. So it's important to consider that when we bring in automation, we also can bring in automation of a failure. But predominantly, the main reason that we can use automation, of course, is to make sure that we can do other things and focus on less of the kind of consistently boring tasks and focus more on the ones that are of interest to us. But also, it does actually, assuming it's set up correctly, will allow us to reduce those mistakes as well, as long as it's implemented correctly. And so we'll be looking at some of that today. I think it's key to just highlight what cloud has done and what it really brings to applications, because applications are at the core of this, really, with regards to cloud. And if we didn't have applications, we'd have no need to put them in a cloud, and as a result, ensuring that the users can access those applications and use them and make sure that they're performant, available, and secure, of course, is a big part of what we are here to do and help customers with. And really, one of the key things that's changed, I think, if you look at security predominantly, is the fact that a large proportion of the security that we've done in the past has been focusing on running. Well, it means that something has had to talk to something else, or run in runtime, or has had to interact at a runtime level of some sort. That's not to say that we haven't had tools that have gone and scanned, static code, or haven't had tools that are running throughout the deployment of our applications. But actually, if we look at the just general industry and what's been demanded from the security industry out there, it's a large proportion around, let me provide you visibility into things that are running, that are communicating in a way they shouldn't be, or are interacting with our underlying platforms or users or apps in a way that they shouldn't be. And this is fundamentally where things have been changed. This idea of just focusing on security as a running thing throughout the deployment lifecycle is no more. There's been some term thrown around. I'm sure you've heard the term shift left, which is this idea of implementing security in a thing prior to it becoming a thing, and that's an important piece. The other big changes, of course, have been in the methodologies and the distribution of tasks and of how we get to a running application. The idea to move away from waterfall developments of applications into more agile deployments, the embracing of things like microservices in order to chop up our application and just maintain or build and update, shall I say, parts of our application at a time, rather than having a big monolithic app that we're continuously patching. Then how that proceeds through in build and test onwards into that final deployment is a key change as well. There's been a lot of new tools introduced in this area. There's also been new methodologies introduced, such as DevOps, this idea of connecting development with operations in order to avoid this kind of historic throwing over the fence of that monolithic app. And the minute, of course, it breaks, the whole thing has to go back to the beginning again, rather than just a piece of it, which can be done now thanks to microservices and other types of deployments, such as not just containers, but things like cloud-native Azure services as well, or Azure functions, as an example. The serverless functions allow us to do the same sort of thing. Have a piece of code that's relative to just one part of the application. It needs to be updated or built or fails. We can just patch that up right at the beginning again and pass it back through this process right the way through to the end, of course. Now, the CI/CD piece, it's a key part of this webinar, and the reason for that is because we feel that it's a really good point in which to implement controls as you move from build through to run on that deploy phase. So as a result, we're not going to be excluding build and run from today, but we'll also be focusing on the CI/CD piece as well, that middle piece as we get there. Just to kind of give you maybe a different view of how we move from development through to operations. We're essentially, of course, starting out by building the code in whichever tools we're using. So it may be some kind of content management system where we're going ahead and building an application in there, or maybe we're going to go ahead and just use a raw IDE. The IDEs such as VS Code or IntelliJ, where you actually go ahead and build things like infrastructure as code templates and also code templates for your Python scripts or whatever scripts you have running within your business applications. So that's a key part of the kind of tooling that's used as part of the development and build piece. And we have things like Docker files, which obviously make up the images that we might be using within our applications. Deployed as microservices again, as I said before. You've got this testing phase where your quality assurance engineers are really kind of putting things through its paces, but ultimately, is that necessarily the best place to implement security when it's still being tested and changes are going to happen, or is build a better place, or is deploy a better place? It really doesn't have a specific answer. It's a case of trying to implement controls through here as evenly as possible and at the right steps that make sense for the final goal. And as I said before, when we look at this in the context of security and the context of Azure, we of course have things like Azure Dev, where we can deploy a pipeline from a code template that we build, and then a running app at the end. So really, to embrace all of these really is a key tenet, I think, of security these days, rather than just focusing more on the stuff on the right, which was obviously the running infrastructure, where we've been doing things such as mentioned there, monitoring how things are communicating, ingesting logs, looking at control planes or running infrastructure, looking at anything malicious going on with regards to running registries or so on, malware, all those things that can affect us. And there's been predominantly the big focus of security for many decades. We look at in more of an SDLC view. It's a case of that cycle that I was talking about before, maybe shown a little bit better here in that, of course, just for representation, the kind of typical number of people you'd have in your environment doing these different tasks. You could potentially have hundreds of developers, but just 5 SRE or DevOps people working within your environment. So they are responsible for bringing that all through to production, and as a result, giving them the tools in which they can do that efficiently, and then also bring it back round to the build phase again if needed, as per an agile framework. The idea, of course, is to enable those tools. So CI systems, CD systems are key part of what DevOps engineers use within the, as you say, the CI/CD practices. And they might also be using things like ID. If they are going to be implementing some of the infrastructure code themselves around that application, then they'll be using an ID system or software composition management systems for underlying images. But again, there's really become an overlap of as much as possible between the dev and the ops in order to form a unified environment for the SDLC. As I said, if we look at it in the context of tooling, things like IntelliJ, VS Code, Git, Eclipse could be used to build that code, and that code could consist of Terraform, Python, CFTs. It could be a number of different formats, and a tool that the DevOps team would predominantly be using as well, of course. So it would be something like Jenkins, Azure DevOps, Bamboo, Circle CI, others within the CI process. And that CI piece is actually a really good place to implement security. So a really good way to implement shift left security, in that we could embed tooling within the CI tooling in order to give us a point in time in which, when we're building and deploying applications, we're ultimately also able to review them, review things like images for vulnerabilities, or review infrastructure's code against best practices and so on. So really, in short, those CI tools do allow us to embed security within the lifecycle, and they allow us to really shift left in terms of our strategy. Ultimately, you can keep on shifting left. You can get right into the composition of applications as well. So, tooling such as IAST or SAST, tooling on the application code, software composition analysis is another key area that you want to embed security within the lifecycle. Principally within Azure, we're obviously focused within things like Azure DevOps and the tooling that you're using to build your apps or your code, such as VS Code. So, for example, you're able to go ahead and embed security within VS Code. Now I'll just show you that quickly what it looks like. Just find my application. So here we have Visual Studio Code running, which is actually have some extensions running right now. So let's have a look. I've got the Prisma Cloud extension, which you can go and search on the VS Code marketplace. And as a result of that, you can see that I've downloaded it. I've given it some credentials that are ultimately talking back to the Prisma Cloud platform. Now we'll have a look at that in a second, but what that means is that I have an API-based connection into the Prisma Cloud platform from my desktop-based IDE that I'm in at the moment. So you can go download this right now and connect it to your Prisma Cloud evaluation. I'll show you how to create one of those in a second. And you're able to do the following. So when you have your code running in here, and I've got some Terraform code, for example, that is deploying within Azure, so it's going to go ahead and deploy an Azure storage account with some settings. And I'm also going to deploy a network security rule in my Azure account as well. That equally, I've got some code underneath it as well in order to deploy that. So before I push this through, put it into my CI tool, Azure DevOps, for example, I want to just sanitize it. And this could be somebody in DevOps, or it could be somebody working in the core development team who's built this template. I want to sanitize it first before passing it on further right, shall we say. And what we can do is actually sanitize it in VS Code. So if I right-click on the file, because I've gone ahead and installed that extension, I've got the Prisma Scan extension running here, and another tab will show me that it's running at the top, so I can see that blue moving cursor at the moment. It's going ahead and scanning that, basically parsing that file and looking against dozens of policies which we have running in our Prisma Cloud environment to see whether it's meeting best practices. So to see whether it's meeting best practices against things like the CIS benchmarks, to see whether it's got meeting practices against other policies that we have in there, to understand whether I've potentially got something misconfigured in here that's going to not be in alignment with the guardrails that we wish to implement in our environment. Now, guardrails are a key part of how we go about securing our cloud environments and our cloud-native environments, because we really don't want to hinder dev on DevOps and in the way that they're building and deploying applications. So by putting in certain checks for some of the obvious malpractices that could be done, such as we've got here, where we've gone ahead and found, for example, that port 22 is wide open here, source inbound from any prefix. You can see in the code there, let's pick that up. So whoever's built this code can go in and remediate that straight away before it gets sent back after it's passed through into runtime, because that's where it'd be picked up as well, using Prisma Cloud, by the way. So that's a key thing to pick up on. Again, we've also got no encryption on the transit from this storage account. So as a result, people can use the storage account without TLS, without encryption when connecting to it. So that's definitely something that we want to monitor and avoid that from being an issue. So just go back here again. We've also had a little look at that VS Code environment. Another thing I wanted to show you as well is the fact that we also integrate into Azure DevOps, into CI/CD, into CI tools like Azure DevOps, and we can do the same thing. We can implement that infrastructure as code scanning into Azure DevOps. In fact, we support Terraform, CFTs, and Kubernetes app YAML files for scanning in there at the moment. Again, you can go ahead and download from the marketplace. It's from the Azure DevOps Visual Studio marketplace. So I'll show you what that looks like over here. Go and download this and install it into your DevOps Azure DevOps environment. You will then be able to use it just in the same way. It's interacting with your Prisma Cloud evaluation and to create an evaluation, that's very easy as well. So you just go to our marketplace.paloaltonetworks.com, and you can go ahead and start a 30-day trial, which will allow you to create those access keys as well. So just go to that URL, you'll be able to start up an evaluation right from here for 30 days for free. And then one is that we're going to have to pull down a utility from the Prisma Cloud environment itself. So once you've got your evaluation started, you will see that within your environment, which you will have running in the cloud, you'll be able to go ahead and download this utility here, which is called the Twist CLI tool. Now, the Twist CLI tool is going to allow me to actually scan not just infrastructure as code, which we saw before, but also we'll also be able to scan our images. We'll be able to scan our Docker files and understand whether any vulnerabilities exist in there, and also whether we got any compliance issues. So what happens is you download this utility and you install it back into Azure DevOps by connecting to a feed here, and then we can go and insert it into a pipeline. Now what happens is, to insert a pipeline, we actually have to download it as a universal image. So I'll just show you what that looks like in my pipeline here. So first of all, I want to go and pull from Docker Hub. So I'm going to go log into Docker Hub, of which I have a task here, for example, to do so. And then I'm going to go ahead and pull in the Twist CLI utility into my pipeline, which is going to allow me to use it after I change its permissions and also move its working location as well. And at that point, I can then implement the scan. Now, this scan is going to be not infrastructure as code, but rather is going to scan against my images. Now, as you can see here, I'm pulling an Nginx image, and I'm going to then scan it as part of the pipeline. So we go ahead and run that. We will see that, first of all, I will go and run the Docker, of course. I will go ahead and pull down the running package, the Twist CLI universal package will be installed into my pipeline. And then I'm going to run a CMD command in there in order to change its permissions and also change its working directory. And then after that, it's going to actually use the utility, the Prisma Cloud Compute Scan Twist CLI utility, in order to review that Nginx image that I've pulled down and understand what vulnerabilities exist within it. So here it begins now. But right now what it's doing is it's communicating back just in the same way that the IDE did, back with the running environment, the Prisma Cloud environment. And that is then allowing it to review what that image is made up with. And you can see right here the results. And in fact, if you saw my pipeline, you'll see that I had thresholds set within the pipeline in order to understand where, fail on medium or high or only critical, and also fail whether fixes are available or not as well. So we can see I've got some CVSS scores against these and CVs, in order to understand where I've got things that have actually been fixed and should be patched. And so I can fail an image just based upon that, and right there in the settings in the pipeline, but also overall what the risk is of each of these individual severities. So I've got two high severity issues in this image. That is going to cause my pipeline to fail, because I believe I had it set to medium. So as a result, that's how that works inside Azure DevOps. Now, if we go back into my running Prisma Cloud Compute, I can actually go ahead and understand in more detail really what's happened by looking under vulnerabilities. And here I can see the scan results actually back inside the tool again. So right now I just ran it here. You can see it's failed. and I've got visibility of those two failures right here inside the view. And in fact, not only do I have visibility of the vulnerability failures, but I also have hundreds of compliance checks that are being checked at the same time as well. So we've got a failure on a CIS Docker compliance check right there inside the tool as well. And even more impressive is I can actually dig into the Docker file and understand where exactly those vulnerabilities sit within each layer, of which 11 exist in this Docker file. We can see that here. We can see that this layer here actually has some high severity vulnerabilities, and also this layer has some medium and low severity vulnerabilities, all visible right there inside the tool. That means that you can review this very easily. And of course, that's just for Azure DevOps. In fact, we have a plugin, for example, for Jenkins, same sort of thing. In fact, this image here that was recently was scanned has a lot of critical issues within it. And these are also visible within the Jenkins plugin that we offer. In fact, we have a number of plugins. We have the Azure DevOps plugin, which you just saw, which does not only image scanning like we did, but also infrastructure code scanning like we did in VS Code, but we actually can do it inside the pipeline as well. We've got Jenkins plugins and AWS Code Pipeline plugins for CI/CD and Circle CI as well. So you can go ahead and use these plugins throughout your CI/CD tools, and they'll allow you to obviously do just what I did right now within CI/CD. You've got plugins for the IDEs, and you also get a GitHub plugin as well that you can go ahead and scan in GitHub for software management. So you've got a extensive set of native tools now. Anything that's not here, if you have a tool that's not here, you can just go use the APIs. So you can use that Twist CLI utility and implement it into a CI tool that's not implemented, shall we say, has a native plugin. Or you can also use the infrastructure as code REST API as well to pass a template from other tools. So options are available for tools that are not supported in that list that we just looked at. And also we've got options for both infrastructure as code scanning and also image scanning as well. So the other thing I wanted to highlight, of course, is that we do still focus on the running infrastructure. So some of you might be using Azure Kubernetes service. So we also implement into that. In fact, deployment for runtime is very straightforward. It's a case of deploying our defenders within your Kubernetes service, where we run just one container per each node inside your Kubernetes environment. That gives us all that visibility around vulnerabilities we just saw, but actually from a runtime perspective. So if we just take a look back in the Prisma Cloud Compute again, right there we were looking at Jenkins and also Azure DevOps. But vulnerabilities are also visible in runtime as well, and for your whole running environment. In fact, an overall view can be accomplished very easily, where we can get visibility of all of my running infrastructure across the environment. In fact, got more than that. I can actually go ahead and view, for example, individual images that are running as container in runtime within a given namespace, like this one here, for SockShot, where we can see that we have high, medium, and critical vulnerabilities within these images. We're also checking the compliance just like we did before, and we can also pick up on runtime issues within AKS. So within AKS, for example, I could go ahead and understand whether I've got, such as here, a hijack process, which would give me understanding of actual runtime issues inside the container environment, inside that AKS environment, not just image health and compliance, but also this important piece around, of course, the runtime aspect. In fact, I'll show you what's happening in a bit more detail. We are essentially able to model every single image that you're running as a container in AKS. So if I pick out a particular image that's running right now within, say for example, I've got this one here, I can understand that this particular image is running, and we've behaviorally learned lots of different aspects around that container. So we behaviorally learned what network ports it listens on, and also what network ports it talks on, what file system paths it accesses locally within the container itself, what system calls as well are also used and can be enforced, and importantly, what processes it uses as well. So that then allows us to build up a model of, well, what does a good look like, a normal look like from an individual container perspective, an individual image really running as a container. And the minute that that image moves around or is pulled down and instantiated the next day, we already know what it does, we already know how it communicates and what it should communicate with, and as a result, if it steps out of line, we can immediately take action there in runtime. So that then allows us to view things like, for example here, port scanning issues, data exfiltration from the container itself. Within AKS, all deployed very easily. In fact, Defender deployment, we can give you a Kubernetes YAML file for a Defender. You can deploy it using a Helm chart. You can deploy it using a simple script that will give you to run on top of your Kubernetes environment. So the ability to deploy this type of security is very straightforward. Again, can be done in the same evaluation that we just looked at a second ago. And here within the visibility around runtime, you can see that I'm getting full visibility around what's happened within the container, what's led up to an individual data exfiltration incident. I can export this forensic data, and so we're getting full lifecycle security as a result of Prisma Cloud. We're getting security here as a running container, and then of course we had those pieces of those plugins that we got available for CI tools and utilities that we can implement in other CI tools such as Azure DevOps, and also we can implement ourselves into those IDEs as well. So a hugely powerful platform that caters for all aspects of the build, ship, or build, deploy, and run aspect of my environment across not only containers but also serverless and also hosts and cloud as well. So we've got the aspect there to really understand what's at risk or what's about to be at risk before it's even implemented, thanks to the tools that we can implement into the CI and IDs and runtime environments. What we also can do as well is integrate ourselves into the Azure Container Registry. So we're not just scanning those images in runtime. You can very easily connect in Azure Container Registry. So I'll go over here and implement vulnerabilities in order to implement ourselves into ACR. So any Docker version 2 API compliant registry is valid, but we have a special drop down there for ACI in order to implement ourselves in there. It does the same type of visibility around vulnerabilities and compliance as well. So under vulnerabilities, for example, I can go and look at just images running inside the registry. In fact, you get a great visibility here around images, image vulnerability, shall we say, around image vulnerabilities that are running as containers and the ones that are potentially about to run as containers. So if I pick out a vulnerability at random, and you can see here that I've got a given CVE, we profile every vulnerability out there and understand its risk factors. So, if fixes available, we can build policies to only block the deployment of a image if the fix is available. We can go ahead and make exclusions for certain CVEs. We can look at the running container traits as well in order to understand, well, if I've got containers that have this vulnerability that actually they're running containers. So if I have images that are running with this vulnerability, then they're visible as well. And as a result, I can see here that this vulnerability is across two separate images. This Jenkins image is not running, but actually this particular other image is running here. And so that I would go and patch that straight away, because that's certainly priority. Not only is it within an image, within the registry, but also within a running environment as well. So it's a key aspect of the whole lifecycle security. You can implement security from the registry, not only just the runtime of your container environment, and also CI and IDs, as we saw before. And just kind of giving you an overall view of what Prisma Cloud's about. We were able to help with a whole aspect, different aspects that I haven't had a chance to cover today. Obviously, today focusing more on the CI/CD and Azure. What we have is full lifecycle security in respect to Azure itself. So we've got a configuration management database that's running against Azure. We're ingesting in dozens of APIs continuously off Azure and giving us visibility around how it's put together from a control plane best practices. So similar to what we saw with the infrastructure as code scanner for best practices, but actually in runtime. So that's all part of the tooling natively. And we have this ability, of course, to then benchmark that against best practices, which gives us great compliance reporting. In fact, we've got about 10 separate compliance frameworks available for Azure, so not just CIS and GDPR, PCI, but also a couple of NIST frameworks, SOC 2, and others that allow us then to see how we're running from an overall compliance stature in there. We look at the flow logs inside Azure and understand anything that's anomalous from a flow log perspective, or even just marrying that up with vulnerability data on hosts and understanding whether we have any hosts that are accepting traffic inbound right now. So similar to what we saw with the individual container traits in AKS, but more also a VM level as well, an IaaS level within Azure. We're going ahead and understanding if you've got any malware within your Azure blob storage. So, if you've got any data types that shouldn't be exposed in the way that they are. We've got the whole data security within our cloud native security platform around Azure. And we've obviously got that ability as well to provide security at an individual workload level as well as an overall Azure level as well. So after all that, we can go ahead and respond to it. We can go change, configuration that doesn't accord with best practices, or we can obviously respond to workloads that have got running vulnerabilities or that are about to have running vulnerabilities. We can fail the build like we did there in Azure DevOps. We can go ahead and pull down containers or also stop processes and other things in order to provide security around running infrastructure. So it's really the first and only full cloud native security platform out there that caters for what is referred to sometimes as cloud security posture management, which is that bit around securing Azure itself, for example, and then also a cloud workload protection platform, which is more around securing those workloads that we saw within containers and cloud native workloads. So that's what Prisma's all about, really. How did we get here? Well, we acquired a few companies along the way, and more recently acquired a company called Operator, really niche, or really a big player in the micro-segmentation space and app sensing space. Last year we acquired a couple of companies in the workloads space. The year before that in cloud security posture management, and we've had support for inline security many years now. So really have built up not only a set of acquisitions, but actually unified them. So it's one platform now, one UI that you can go ahead and evaluate yourself and get to the point where you actually have this full running DevSecOps platform. It's actually a way in which you can implement security into CI/CD, for example, like we did today with Azure DevOps. Can implement into those security into IDEs and registries, repos, GitHub obviously we saw there. We can do the whole security around the runtime environment inside Azure, but also the workloads that are running within AKS. Or if you're just running workloads on top of OpenShift inside Azure, or you're running managed or unmanaged Kubernetes servers within Azure, can cater for that. Exactly the same type of protection that we saw today is available for those as well. So the Prisma Cloud platform really is an all-encompassing cloud-native security platform today. One UI, all you can manage it yourself, or you can manage it, or we can manage it for you as SaaS. It's really up to you how you want to consume it. And lastly, I just wanted to kind of highlight out this Cloud Native Security Live Summit that we have coming up, February 11th. This is going to be an all-day session with speakers not just from Palo Alto Networks, but we've also got some of our customers and other people talking, industry experts, looking at cloud native, cloud and other securities, serverless. We have various different speakers coming as part of that on the virtual summit. So I trust that you will find that very informative, and please do sign up. In fact, you should have seen the registration link within the invitation that you've signed up for this webinar. So it should be encompassed within there as well. So I just want to take this opportunity to see if we've got any questions in. Okay, yeah. So I will just have a little read through them. We have got a couple. Image scanning for containers can be used across EC2 instances as well as runtime. So that's a question around image scanning for EC2. So if those are EC2 instances running as just VMs, or if they're running, so it's not quite clear in the question, but basically the question is around image scanning is for containers only. What about EC2 instances? So I assume you're referring to like Linux or Windows machines running on EC2. And the answer to that is yes, absolutely. In fact, if we just go back to I'll just share my screen again. If we go back to the overview, sorry about this, I'll just show you what the image scanning looks like. So under hosts, this is us actually scanning hosts inside cloud environments as well. So I've got Ubuntu images there. They could be running on top of EC2. They could be running on Azure as well. It really is not an issue. So we've got the ability to run even image scanning on-premises machines. So whether you're running IaaS or containers or serverless, we have defenders for all of them, looking at vulnerabilities, looking at compliance. There's even workload-based firewalls inside there. So it really is a bit of everything inside that. And